everyone. Today we will be talking about logic in discrete structures, a fundamental concept in computer science and mathematics. Understanding logic is crucial for designing algorithms, proving the correctness of programs, and more. So here's what we have lined up for you.
Let's start with the first topic, which is statement. A statement or proposition is a sentence where the true value can be determined. This true value is either true or false, but never both. Let's explore this concept with a simple example. The teacher asks, how many vertices does a cuboid have? The student then responds with two possible answers, which is, a cuboid has 8 vertices and a cuboid has 12 vertices. Only one of these statements is correct, which illustrates the principle that a statement must be either true or false. Now, let's determine whether each sentence below is a statement or not, and justify your answers. For the first sentence, Kuala Lumpur Tower is the tallest tower in Malaysia. This is a statement because its true value can be determined, which is true. For the second sentence, please send the workbook. Now this is not a statement because it is a command, and its true value cannot be determined. Lastly, for the third sentence, -6 is lesser than -8. This is a statement because its true value can be determined, which is false. In logic, we often replace statements with variables such as P, Q, R, or S to simplify reasoning. These variables stand in for specific statements, allowing us to focus on their logical relationships. Let's consider an example. Let P represent a pentagon has 2 diagonals. Then let Q represent a heptagon has 4 diagonals. By using this variable, we can analyze logical structures without getting bogged down in the details of the specific statement. Now, let us get into the next topic, which is compound statement. We will explore the logical connective and, also known as a conjunction. It's written as P conjunction Q, and it combines two statements in such a way that the conjunction is true only when both P and Q are true. For example, P is today is Friday, Q is it is raining. Conjunction P-Q represents today is Friday and it is raining today. This statement is true only if both today is Friday and it is raining. Let's apply the conjunction rule to a couple of scenarios. Problem 1. P. We are traveling to Japan. Q. We are packing our bags. The conjunction PQ is we are traveling to Japan and we are packing our bags. Problem number 2. P. The car is parked. Q. The engine is running. Conjunction PQ is the car is parked and the engine is running. In both cases, the combined statements are true only if both individual statements are true. Next, we will explore the logical connective OR, also known as a disjunction. It is written as P disjunction Q, and it combines two statements in such a way that the disjunction is false only when both P and Q are false. For example, P, today is Friday, Q, it is raining. The disjunction P-Q is false when both P and Q are false and is true otherwise. Let's apply the disjunction rule to a couple of scenarios. Problem 1. P. I will go for a walk. Q. I will stay home. The disjunction PQ is I will go for a walk or I will stay home. Next problem is P. The water is boiling. Q. The water is frozen. The disjunction will be the water is boiling or the water is frozen.
For the last compound statement is negation. Negation for any statement P is not P, written as not P or not P. For example, it is not the case that P, which is the proposition negation P, is read as not P. The true value of the negation of P is the opposite of the true value of P. The example for this negation is number 1, the sky is blue. So the negation of P is the sky is not blue. Number 2, all students pass the exam. The solution for this is negation P, which is not all students pass the exam. Number 3, the car is red. The solution is the car is not red.
Moving on to next topic, conditional statement. Implication. The compound statement is if P then Q also can be written as P arrow Q. For example, P P, I am hungry, and Q, I will eat. The implication would be if I am hungry, then I will eat. Next example is P, it is cold, and Q, 3 plus 5 equals 8. The implication would be if it is cold, then 3 plus 5 equals 8. There are 4 types of implication. The first one is conditional. The definition is if P, then Q. And the example is if it is raining, then I get wet. The next one is converse. The definition is reverse for the conditional. The example is if I get wet, then it is raining. The next one is inverse. The definition is negates the conditional. The example, if it is not raining, then I do not get wet. The last one is contrapositive. The definition is reverse or the inverse. The example is if I do not get wet, then it is not raining.
Hello again. In my part of the video, I'll be discussing logically equivalent statements. First, let's talk about what it means for two statements to be logically equivalent. Two statements are considered logically equivalent if they have the same truth value in every possible scenario. This is often expressed using the biconditional operator written as P if and only if Q, or symbolically as P equal to Q. Essentially, P and Q are equivalent if they are either both true or both false. Let's explore three key types of logical statements: tautology, contradiction, and contingency. For tautology, a statement that is true no matter what the truth values of its components are. For example, P or figuration P is a tautology because it asserts that either P is true or P is not true. Since one of these must be true, the entire statement is always true. Think of it like saying it is raining or it is not raining. P is always true regardless of the weather. Contradiction, on the flip side, a contradiction is a statement that is always false no matter what. An example would be P and negation Q, which states that P is true and Q is false simultaneously. For instance, saying it is raining and it is not raining is a contradiction because both conditions cannot be true at the same time. And the last one is contingency. Finally, we have contingency, which is a statement that could be either true or false depending on the truth values of its components. An example is P and Q, which could be true if P and Q are true, but false if either one is false. For instance, the statement it is raining and it is cold can be true or false depending on the actual weather conditions.
Okay, what's up guys? Now I'm gonna teach you guys how do we do a truth table in physical way. I mean in physical way is someone that teach you. Okay, if the question is P and Q, how do we do the table? Okay, first you guys must know how do we get the value for this table. Okay, first for this table, actually they have formula which is 2 to the power of n. 2 to the power of n. What is n? N is how many value for this, which is this. So we have 2. So we must replace the n with 2. So the answer is 2 to the power of 2. Then 2 to the power of 2 is equivalent to 4. Okay, 4. We got all the value, which is inside the table we must have 4 value. Okay, how do we know the P value? The P value we must divide by another 2, which is the answer is 2. So in true value we only have true and false. So when the answer is 2, we must have 2 for true and 2 for false. Then you just put in P. True, true, false, and false. Like that, okay? Okay, how do we know the Q value? The Q value is, we must divide by another 2 to get the value for Q, which is 1 true and 1 false. So the answer is 1 true, 1 false. 1 true, 1 false. That's the basic way to get the truth table. Now, we move to the next agenda, which is P and Q. Okay, P and Q. First, we look at P and we look at Q. True and true, the answer is true. Why? Because let's just say if your teacher say to you to bring a pencil and eraser, so you must bring both to get in the exam, right? So if true and true, so the answer is true. You guys must bring both to get in an exam. Okay. Number 2. If true and false, the answer is false. Because, like the example just now, if the teacher say to you, you must bring pencil and eraser, so you must bring both. You cannot bring either. So if you bring either, then the answer is false. True or false, the answer is false. In this conditional, you must prioritize the false. False and true. So the answer is false. Like I said just now, because you must prioritize the false. Next is false and false. False and false. Like I said just now, the example, if the teacher said wrong, which is the wrong sentence and wrong sentence, you cannot choose the right one. So you must choose the wrong sentence, which is false and false. Okay, for the next one, I'm gonna teach you guys about P or Q. What's the difference between P or Q is, P or Q, we must prioritize the true. If P and Q, we must prioritize the false. So that's the difference. The susunan is still same. 2, the power of 2, equivalent to 4. So we must divide by 2 to get the how much true and how much false. Next, we must know how to calculate this. Okay, true or true? True or true? The answer is true. True or false? The answer is true, because, for example, if the teacher say you must bring pencil or pen, so you can either choose one. So true or false, the answer is true. Yes, like that. Okay, if false or true, the answer is still true, because true and false, true or false, and false or true is still same. So if false or false, the answer is false. False or false and true or true is same. So if true or true, the answer is true. If false or false, the answer is false. Okay, moving on for the next one. The next one is negation. What is negation? Negation is the opposite of the truth value, which is P or Q, negation of Q. Okay, same goes as the value same as the previous one, which is 2 the power of 2 equivalent to 4, which is all of this. Divide by 2 to get the 2 true and 2 false. Divide by 2 again to get the value of Q, which is 1 true, 1 false, 1 true, 1 false. How do we do this? How do we do the table is, we must do the negation of Q first. Okay, negation of Q. Negation of Q is the opposite of Q, which is true. What is the opposite of true? Is false. False, true. True, false. False, true. We're not done yet. The last one we must write here is all of this, which is P or negation of Q. Then we write P or negation of Q. So we look at P and then we look at here. Yes. So the answer is true or false. True or false is true, right? True or true is true. False or false is false. False or true is true. Yes, like that. So this is the last answer for this question. For the last one for truth table is if P then Q, which is the question would be like this: P then Q. So it's just an arrow, just like that. P and Q. So how do we do this? Just do the basic one: T, T, F, F, T, F, T, F. If P then Q, if true then true, which is the answer is true, because it's same. True and true. So it's same. For true and false, if true and false, the answer is false, because okay, for how I understand this topic is I just follow the Q. I just follow the last one. So if true or false, we just look at the Q. So the answer is false. False and true, the answer is true. Yes. Okay, for false and false, it's same. It's same, just like this. It's same, just like this, right? Okay, it's same. If it's same, false and false, so the answer is true. If same, true. If different, you guys must look at the Q, which is true false, so the answer is false. False true, so the answer is true. Okay, I think that's all from conditional statement.